Hi, this video is about APR, APY, and more generally just the effective rate. All right, so if you get a loan or go to invest money in a savings account, or if you get a credit card, you'll usually see the terms APR or APY thrown around. So what does that mean? APR is the average percent rate. So you'll see that term if you're borrowing money. And APY is the average percent yield. So that's the term you'll see if you're investing money. So these are actually calculated the exact same way, and we can call them both by this phrase effective rate. And we'll denote that by R with a little EFF in the subscript. Okay, so what is the purpose of the APR, APY, or effective rate? So essentially, the way I see it is that the effective rate helps you compare apples and oranges. So say one bank is telling you that you can borrow money at a rate 2%, but it will be compounded monthly. And a different bank is telling you you could borrow money at the rate 2.5%, but it will be compounded quarterly. Which one's going to be better? Without having the APR, then you would have to do some math, figure it out to see how much you'll be spending in each scenario. To kind of help things along so that people don't have to think so hard, the US government usually has banks and credit cards give out the APR, APY, or the effective rate. So instead of having to do all the number crunching yourself, the banks will do that for you. And then you can just compare those APRs against each other to see which one's better, or you can compare the APYs to see which one's better. Okay, so let's calculate the effective rate. In the example where we had a loan for Katara for $100, the rate was 2%. She is borrowing it for 3 years and we're compounding it quarterly. So since we're looking at the annual percent rate or the effective rate, we need to look at the amount accumulated after 1 year. So after 1 year, since she is getting her interest compounded quarterly, then she has 4 times that it's getting compounded. So using our equation that we've been using throughout, A equals P times 1 plus R over the number of compounds in a year to the number of compounds in the year. So we've got A equals P times 1 plus R over 4 to the 4. So plugging in R equals 2 and P equals 100, we see that the amount accumulated is $102 and 1.505 cents. So in other words, she's going to have to repay you that much money after 1 year. So now a good question to ask would be, okay, so say that you had the option to just do a simple interest rate. What simple interest rate would turn $100 into $102.01505 in 1 year? We have the equation, the same old equation as always, A equals P times 1 plus R. And P in this case is 100, and the amount, we are setting it up to be 102.01515 so that we can answer this question here. So now what we're looking for is this effective rate. We're wondering what's that effective rate. So what we can do is just solve for that effective rate. So first thing we need to do is divide both sides by 100. And then now that means that on the right-hand side, we have 1 plus the effective rate. So to solve for the effective rate from here, we need to subtract 1 from both sides. So the effective rate is 1.0201505 minus 1. So in other words, the effective rate is 0.02015. And there's some more decimals there, but we'll just stop there. Okay, so that is how we can calculate our effective rate. And actually there's a shortcut formula so you don't have to calculate that whole thing yourself every single time. And our shortcut formula is right here. The effective rate can be calculated from the nominal rate and the number of times that it's compounded in a year. So M is the number of times it's compounded in a year, and R is the nominal rate. So we can calculate that effective rate according to this. So just to do it in the example that we just did up here where we found 0.02015, just to do it again to make sure that we get the same answer. We plug in our rate of 2% or 0.02. We plug in 4 because we're compounding quarterly. We put a 4 up there as well because, again, quarterly. So we have 1.005 to the 4 minus 1. And if we crunch that out in our calculator, we get 0.02015 with more decimal places, or in other words, 2.015%. So that 2.015% is the effective rate. So remember, 2% was the nominal rate, 2.015 is the effective rate. And as we can see, the nominal rate here, 2%, is smaller than the effective rate, 2.015%. So what that means is that, say you're going to be investing money into a savings account, banks will often advertise just the saving account's effective rates, or in other words, the APY, instead of the nominal rates, because the effective rate is greater than the nominal rate, and they want to show you a bigger number because they're excited, and they're hoping that maybe they'll confuse you and you'll think that there's no difference between the effective rate and the nominal rate, so that you'll choose their plan and get more money, and they'll get more money out of you. All right, so that's how we calculate effective rate, and that's also called APY in the event that you're investing, or it's called APR in the event that you are getting a loan from the bank.